All right, hello everyone. I'm Chris Fenner from the WA Department of Primary Industries and Regional Development. And I'm talking today about a field trial in using different coloured sticky traps and lures in biosecurity surveillance of Hemiptera. I'd like to start by acknowledging the Whadjuk Noongar people as the traditional custodians of the land where this work was done, and pay respects to their elders past, present and emerging. And sorry, not going to the next slide. Okay. So biosecurity surveillance is an escalating cost as global trade and travel create avenues for invasive pests such as the brown marmorated stink bug and Asian citrus psyllid pictured. Targeted surveillance increases the likelihood of an early detection and an effective response, but it is more costly. So we look at ways to target multiple species from one trap for more efficient sampling. Hemiptera can be vectors of plant diseases, such as zebra chip disease in potatoes, which is spread by tomato potato psyllid. TVP established in Perth in 2017 and has since spread to areas of the south and west of WA. DPIRD's biannual surveillance gathers data on the distribution of this pest, and since 2019, 6 other state and territory departments have participated in national psyllid surveillance. So given we have an established surveillance program for a Psylloidea, we decided to value add by testing methods to trap other Hemiptera. This graphic shows the experimental design. So our participants were given a tomato plant, which is on the left, with a yellow and a green sticky trap and a lure attached to the yellow trap. And about 2 meters away, they placed a citrus plant with another yellow trap. The lure was one of 4 types: brown marmorated stink bug, Asian citrus psyllid, BMSB or ACP combined, and the control group, which of course had none. We recruited volunteers from among DPIRD staff and their friends and family, and a few interested community members, and chose people who had participated in surveillance before and who we recorded TPP at their property in the past. And then we also were looking for a good spread across metropolitan Perth and the peri-urban outskirts. And here you can see the experiment in practice. We use the My Pest Guide Reporter app to gather location data and provide feedback to participants. You can see this person has kept their Morea citrus plant in a pot on the left and planted out their tomatoes in the veggie patch with its 2 traps. The trial lasted 4 weeks in the field in October last year, with traps returned weekly to our labs. Just some quick numbers, 820 traps were collected from 104 premises. Over 9,000 insects were identified morphologically, and half of those are TPP. The rest of the psyllids mostly were native Achisia species. And the Pentatomidae capture was quite low, only about 30 of the Claudia affinis, common stink bug, and just 1 or 2 other individuals. Our first graphs here plot abundance against the 3 trap types on the x-axis, the white for this yellow trap on a citrus plant, the green trap, and the yellow trap on a tomato plant, sorry. Is the red column. And we compared 3 taxa, TPP up the top, the rest of that family Triosidae below that, and then the greater superfamily Psylloidea in the bottom right. So you can see immediately a strong preference for the green trap among all those groups, while TPP being a tomato feeder, it's not really surprising that it avoided the citrus there. Again, we plotted abundance, this time against the 4 lure types. You can see in the TPP graph at the top, it was fairly unenthusiastic about the 3 lures and preferred the control group. But among the other Triosidae below that, they seem to be attracted to the lures. It seems that black column with the combined lures, they're probably interfering with each other and causing some avoidance there. But surprisingly, in the rest of the Psiloidea, the stink bug lure actually attracted the most. And here we've just plotted abundance over time. So again, comparing those 4 lures, but this time the abundance at each of the 4 weeks. And there is a slight trend towards a spike in abundance in week 2 in most of those categories, followed by a decline in the later weeks. And when we looked at the weather over that time, the first week was cooler and wetter than we'd hoped for, but then got warmer in the second week and then dried out after that. So thinking about ideal conditions for insect activity, it was definitely warm but still damp after recent rains in that second week. So we can see that the effect of lures on non-target species was unpredictable, and TPP was repelled by both of the lures we used. So we sought some answers in the literature and found the ACP lure uses organic volatiles present in fresh citrus, as well as clove oil, which is derived from the genus Syzygium, where we also get lily-pilly. And indeed, the lily-pilly psyllid, Triosa adventitia, was attracted to the lure in our trial. While in some other trials, clove oil has produced avoidance behaviour in TPP. So we think we have a culprit there with what's obviously a strong ingredient in the lure. The pentatoma data, it seems, I'm sorry, remembering this mostly comes from the one species, Claudia affinis. At the top, it seems the stink bugs didn't prefer one colour over the other. This species feeds on tomatoes, so it's not really present in the citrus, but is present on the 2 tomato traps. But the difference between the green and yellow isn't significant. Below that, however, it definitely was attracted to the lure, the BMSB lure on its own and combined with the ACP. We would suggest that the ACP lure actually has no effect on the stink bugs, but that huge discrepancy in the 2 columns there is probably just a function of the small sample size. And in the bottom right, the abundance over time, there's definitely a big decline after week 2, which suggests to us that perhaps the lures wear out over time as the chemicals degrade. So as we just saw, the BMSB lure attracted the unrelated stink bug, Claudia affinis, but a pheromone of Claudia stahli from the same genus is used in the lure, so that's likely to have attracted it there. The lack of other species captured suggests they weren't attracted to the lure at all. Combining lures doesn't appear to inhibit capture in the stink bugs, but the effectiveness does decrease over time. Just in summary, olfactory cues were more influential than colour, and in surprising ways that deterred our target insect TPP. The lures based on plant volatiles attract a wider range of fauna, and the effects can be somewhat predicted by studying the ingredients, while pheromone lures are more specific and it's harder to predict attractants patterns except by trial and error. Unfortunately, neither the ACP or BMSB lures are useful in TPP surveillance because they're both a deterrent to the pest. But the green coloured traps were the real winner in this trial. They yielded greater diversity and abundance in the Psiloidea, and we've already started employing those in our surveillance. And that's all. Thank you for listening.
Thanks very much, Chris. We've got heaps of time for questions, so has anyone got anything to ask? If you don't mind stopping your screen sharing, Chris,
Sure.
that'd be great, if that's right. I can't see people at the moment. Yeah, if anyone wants to put their hand up or shout out.
Hi, I have a very quick question. Great talk, Chris. I was wondering, I noticed it's very interesting to me how you notice a variation between triosids and all other Psiloidea. And I was wondering if, so you said most of the other Psiloidea are Achistia. Did you went any farther in identifying, like, so for example, I was suspecting mostly family Psyllidae.
Yeah, so Akizia is in the Psyllidae. We didn't get much further than genus level identification just because of time.
Fair enough. Fair enough.
Yeah.
That's very, very interesting. Yeah, I would be very keen to just expand, as much as you can to any other species, and just compare differences in genera and families. It's really surprising to me. I wouldn't have expected, and it's pretty cool.
Yeah, definitely. And I mean, a superfamily is a big group to be looking at. So yeah, lots of room to explore those differences, and it was surprising seeing even species of different families being attracted where you might not expect them to be. And yeah,
good stuff.
Thanks for that, Francesco. We've got another question in the chat, Chris. Donna's asked, have you measured the wavelength of the green traps? And she said, we found green traps were attractive to fruit spotting bug also. Now, I'm not going to read out the Latin.
Sure. We haven't done any investigation into that ourselves. The traps were developed with Asian citrus psyllid in mind, and that colour vision among Psylloidea. So yeah, not surprising that then other Hemiptera are also attracted. Yeah.
Thanks. Are there any more questions? We've got time for a couple more. What are your next steps, Chris? You said you're deploying the traps for further monitoring now, but what's the end game?
Yeah, end game I think was just to refine our processes, and yeah, so we've been doing this monitoring for TPP around the state, and it's still continuing in Kununurra, that tropical growing region. And yeah, we just found using these green traps, we catch a lot more species, so it's really been helpful to us. And yeah, they're a bit harder to get than the yellow ones. They're much more common in Australia, but yeah, they're very useful. So using them as much as we can.
Oh, fantastic, thank you.
So Sam, if I can just cut in, it's Melinda here.
Melinda.
Hi, we would have loved to have taken things a lot further, but we were incredibly short on time. And as I know, Francesco's got lots of interesting ideas that he could do with it, but it was very specific. It was for a very specific purpose, this study, as many of the people who are watching already know. So we had to cut it short and sharp and move on to the next thing. So we've done what we can with it, but we understand New South Wales are also doing their own study between green and yellow traps. So it'll be very interesting to hear what they have in the future, what their results are.
Oh, fascinating. Now, I know it's work that we've looked at with aphids before in the past as well. And yeah, I think it's a fantastic tool to have for the monitoring. So thanks for that.